So here I have question number 89. We want to convert from rectangular units to polar, right? So we have -3, 4. We want to convert that into the form r, theta. So if you recall, obviously we know that x squared plus y squared is equal to r squared, right? From the Pythagorean theorem and from the right-angled triangle we had drawn earlier on that circle. And so here we know that if x and y, well, if x is -3 and if y is +4, squaring them, you get 9 plus 16 is equal to r squared. So we know that 25 is equal to r squared. Well, then r must be plus or minus 5. So we know that r squared is equal to 25, therefore r must be plus or minus 5. Again, that -5 is referring to that opposite direction. So it's important to understand that obviously the radius can never be actually negative. It's a positive value, but that negative here refers to that direction. So we can have a different notation that means the same thing, but we can use that -5 as well. So we know our r. Now to determine our angle theta, we can use this one over here. The tangent of theta is equal to y over x, right? That idea of opposite over adjacent. So that y over x in this case would be -4/3. So you would do tangent inverse of -4/3 to determine your angle theta, right? And so you do that, and if you want, you can put that in your calculator, doing the inverse of -4/3, right? Tangent inverse of -4/3, and the angle that you should get, right, is 126.87 degrees. So now you know your angle. Obviously it does not give you two angles, it only gives you one specific angle over here, right? But if you think about this, this is referring to the angle in quadrant 2, right? 126.87 degrees is in quadrant 2, and our point over here, -3, 4, that is also in quadrant 2. However, we must understand that when we're evaluating this, theta could also be a possible value in the fourth quadrant, right? You can have a value that you get in the fourth quadrant too, because tangent in the fourth quadrant is negative. So if you know your reference angle here, right? If you know what your reference angle here, you should understand that this must be equal to 306.87 degrees, right? If you know your reference angle. So if you for instance, if I do find a second tangent, right, of 4/3, then I know that's 53.13 degrees, right? And looking at this, obviously, if we go from the clockwise direction, right, and subtract this value here from 360, we get 306.87 degrees. So we know that this is a possible angle. However, we know that our coordinate point is still -3, 4. So really, when we're talking, your teacher may or may not ask you, but it's always good to understand this conceptually. There are four notations, right? Your first notation here would be 5, 126.87 degrees. That's your first form when you're writing, because obviously you know your radius is 5, right? Comma 126.87 degrees, right? You're moving in that direction towards that angle of 126.87 degrees because you know your coordinate point x, y is also in the second quadrant. Then you have your second possible one. Again, you have 5, -233.13 degrees. This is really nothing but saying that, oh, instead of going counterclockwise, you're going in the clockwise direction. So that's why I subtracted 360, right? 360 from 126.87 to get that negative angle, -233.13 degrees. That's just going in the clockwise direction, but it means the same thing. Then we have the third possible one. Now this is interesting because this one is -5, 306.87 degrees. Now we know that this is a possible angle. It works, right? Because tangent in the fourth quadrant is negative. It does give that -4/3. However, we know that our x, y is in quadrant 2. Therefore, we can write this, but we want to bring this negative radius, right? This -5 that we had here, which indicates that, oh, it's in the fourth quadrant, right? But however, it's -5. Therefore, we need to go in the opposite direction. So we go here, and that lands in the second quadrant then, right? So this notation here, although has this angle, is really referring to the second quadrant because of this -5. And then our fourth notation would be just to keep this -5, however, say, comma, -53.13 degrees. Again, -53.13 degrees and 306.87 degrees refers to the same position on the circle, right? Although they are two different angles, it's the same thing, because this one's going in the clockwise direction and this one is going in the counterclockwise direction. So that's question number 89. Thanks for watching.